Image 320 light-years from Earth. The star W Hydra is a few billion years further on than the Sun in its life. For comparison, the dotted ring shows the size. View more. Credit Alma ESONAOJNRAOW. Vleming's A. Chalmers-led team of astronomers has for the first time observed details on the surface of an aging star with the same mass as the Sun. Alma's images show that the star is a giant, its diameter twice the size of Earth's orbit around the Sun, but also that the star's atmosphere is affected by powerful, unexpected shock waves. The research is published in Nature Astronomy on the 30th of October 2017. A team of astronomers led by Wouter Vlemings, Chalmers University of Technology, have used the telescope Alma Atacama, a large millimetry submillimeter array, to make the sharpest observations yet of a star with the same starting mass as the Sun. The new images show for the first time details on the surface of the red giant W Hydra, 320 light-years distant in the constellation of Hydra, the water snake. W Hydra is an example of an AGB asymptotic giant branch star. Such stars are cool, bright, old and lose mass via stellar winds. The name derives from their position on the famous Hertzsprung-Russell diagram, which classifies stars according to their brightness and temperature. For us, it's important to study not just what red giants look like, but how they change and how they seed the galaxy with the elements that are the ingredients of life. Using the antennas of Alma in their highest resolution configuration, we can now make the most detailed observations ever of these cool and exciting stars, says Wouter Vlemings. Stars like the Sun evolve over timescales of many billion years. When they reach old age, they puff up and become bigger, cooler and more prone to lose mass in the form of stellar winds. Stars manufacture important elements like carbon and nitrogen. When they reach the red giant stage, these elements are released into space, ready to be used in subsequent generations of new stars. Alma's images provide the clearest view yet of the surface of a red giant with a similar mass to the Sun. Earlier sharp images have shown details on much more massive, red supergiant stars like Betelgeuse and Antares. The observations have also surprised the scientists. The presence of an unexpectedly compact and bright spot provides evidence that the star has surprisingly hot gas in a layer above the star's surface, a chromosphere. Our measurements of the bright spot suggest there are powerful shock waves in the star's atmosphere that reach higher temperatures than are predicted by current theoretical models for AGB stars, says Theo Cowrie, astronomer at Chalmers and member of the team. An alternative possibility is at least as surprising: that the star was undergoing a giant flare when the observations were made. The scientists are now carrying out new observations, both with Alma and other instruments, to better understand W Hydra's surprising atmosphere. Observations like these with Alma's highest resolution configuration are challenging, but also rewarding, explains team member Elvire de Beck, also astronomer at Chalmers. It's humbling to look at our image of W Hydra and see its size compared to the orbit of the Earth. We are born from material created in stars like this, so for us it's exciting to have the challenge of understanding something which so tells us both about our origins and our future, she says. More about the research. The results were presented in the paper The Shock-Heated Atmosphere of an Asymptotic Giant Branch Star Resolved by Alma, published in Nature Astronomy on the 30th of October 2017. The team is composed of Wouter Vlemings, Chalmers University of Technology, Sweden; Theo Cowrie, Chalmers University of Technology, Sweden; Eamon O'Gorman, Dublin Institute for Advanced Studies, Ireland; Elvire de Beck, Chalmers University of Technology, Sweden; Elizabeth Humphreys, ESO, Boilunkar, Chalmers University of Technology, Sweden; Matthias Marker, Chalmers University of Technology, Sweden; Hans Olofsson, Chalmers University of Technology, Sweden; Sophia Ramstedt, Uppsala University, Sweden; Daniel Tafoya, Chalmers University of Technology, Sweden; and Aki Takagawa, Kyoto University, Japan. More about Alma and Onsala Space Observatory. The Atacama, a large millimeter-submillimeter array Alma, an international astronomy facility, is a partnership of ESO, the U.S. National Science Foundation (NSF), and the National Institutes of Natural Sciences (NINS) of Japan in cooperation with the Republic of Chile. Alma is funded by ESO on behalf of its member states, by NSF in cooperation with the National Research Council of Canada (NRC) and the National Science Council of Taiwan (NSC), and by NINS in cooperation with the Academia Sinica in Taiwan and the Korea Astronomy and Space Science Institute (CASI). Chalmers University of Technology and Onsala Space Observatory have been involved in Alma since its inception. Receivers for the telescope are one of many contributions. Onsala Space Observatory is host to the Nordic Alma Regional Center, which provides technical expertise to the Alma project and supports astronomers in the Nordic countries in using Alma. Onsala Space Observatory is Sweden's national facility for radio astronomy. The observatory provides researchers with equipment for the study of the Earth and the rest of the universe. In Onsala, 45 kilometers south of Gothenburg, it operates 2 radio telescopes and a station in the International Telescope LOFAR. It also participates in several international projects. The observatory is hosted by Department of Earth and Space Sciences at Chalmers University of Technology, and is operated on behalf of the Swedish Research Council. Disclaimer: AAAS and Eureka Alert are not responsible for the accuracy of news releases posted to Eureka Alert by contributing institutions or for the use of any information through the Eureka Alert system.